Welcome to Karna Maths Academy. Today, in this lecture, we are going to discuss exam question answer hseb NEB 2064, question number 14, Group B. Question number 14. Draw the graphs of the following inequalities. Draw the graphs of the following inequalities: 6x plus 5y less than or equal to 30, x greater than or equal to 1, y greater than or equal to 2. Solution. So this is the problem of linear programming. Now, according to this question, we have to draw the graphs of the given inequalities, and we have to find the feasible reason. Solution. Given 6x plus 5y less than or equal to 30, the first inequality, x greater than or equal to 1, second inequality, and y greater than or equal to 2, third inequality. That means we are given three inequalities, and we have to draw the graph of the given three inequalities, and we have to find the feasible reason and determine the vertices of feasible reason also. So the first step of linear programming, or we can say the first step to draw the graphs of the given inequalities, we have to change the given inequalities into their corresponding equation. Changing the given inequalities, the inequalities we can say constants also, that means conditions. Changing the given inequalities into corresponding equation. 6x plus 5 y less than or equal to 30. The corresponding equation of the first inequality is 6x plus 5 is equal to 30. The corresponding equation of x greater than or equal to 1 is x is equal to 1. And the corresponding equation of the third inequality is y is equal to 2. Now, first we have to make the table values of the given inequalities in order to plot in the graph. 6x plus 5 is equal to 30. The table values of the first equation, that means 6x plus 5 is equal to 30. Let's solve this equation for y. Solving the given equation, solving the first equation for y, so that easily we can find the values of x and y. 5y is equal to 30 minus 6x. Y is equal to 30 minus 6x divided by 5. Therefore, y is equal to 30 minus 6x divided by 5. The value of y is 30 minus 6 divided by 5. That means we have solved the first equation for y, so that we can easily find the values of x and y. Now, choosing the value of x, the variable x is on the right hand side, or we can say y is function of x. So choosing the value of x. So let's choose the value of x 0. So for our convenient, we have to choose the value of x 0. Next time we have to choose the value of y is equal to 0, so that easily we can plot in the graph. So when we choose the value of x is equal to 0, 6 into 0 will be 0, 30 minus 0 is 30, and 30 divided by 5 is 6. That means the value of y is 6. So when we put the value of x 0, then the value of y gives 6. Now choosing the value of x 5, because if we choose value of x 1, 2, 3 and 4, then the value of y will be in fraction. In order to avoid the decimal numbers of fraction values, we have to choose the value of x so that the number is easily divided by 5. That means we get the value of y in the whole number. So we have to choose the value of x so that such that the value of y is a whole number. So if we choose value of x 5, we get 6 5 is 30, 30 minus 30 will be 0, and 0 divided by 5 we get 0. That means when we choose the value of x 5, the value of y we get 0, which is a whole number. So we have to choose the value of x such that the value of y is a whole number. Now if we choose value of x 6, 7, 8, 9, then the value of y will not be a whole number, we'll get a decimal number, or the value of y will be in fraction. Again, if we choose value of x 10, 6 10 is 60, 30 minus 60 is minus 30, minus 30 divided by 5 is minus 6. That means when we choose the value of x 10, then the value of y will be minus 6. So we have to find at least 3 values of x and y. We have to find at least 3 points, so that easily we can plot the equation in the straight line. We can easily plot the equation in the graph. The second step of drawing the given inequalities in the graph is we have to take the testing point. Already we have found the tail values of the corresponding equation of the first inequality, and now we have to put testing point, because inequalities always represent a certain region. Now in order to identify the region represented by the given inequality, we have to take the testing point. Let's take testing point 0 0. So we can take any point as the testing point which does not lie on the corresponding equation. So if we take 0, 0 as the testing point, the point 0, 0 doesn't lie in the corresponding equation of the first inequality, because if we put x value 0, y value 0, then we'll not get 0 equals to 0. That means 0, 0 doesn't lie in the corresponding equation of the inequality. So while choosing testing point, we have to choose the point which does not lie in the corresponding equation of the inequality. So taking testing point 0, 0. Now if we put x value 0 and y value 0, then 0 plus 0, we get 0, which is less than or equal to 30. That means 0 is less than 30, which is true. That means the given inequality contains the testing point 0, 0. That means the given inequality contains the point 0, 0. So while plotting the graph of 6x plus y less than or equals to 30, we have to show the reason. We have to show the reason towards the testing point, because 6x plus 5y less than or equal to 30 contains the point 0, 0, because 0, 0 satisfies the inequality 6x plus 5y less than or equal to 30. Now it shows that the inequality 6x plus 5y less than or equal to 30 contains the point 0, 0, because 0, 0 satisfies the inequality 6x plus 5y less than or equals to 30. Now the second given inequality is x greater than or equal to 1. The second given inequality is x greater than or equal to 1. Now to plot the graph of x greater than or equal to 1, we have to change into corresponding equation. The corresponding equation of x greater than or equal to 1 is x is equal to 1. X is equal to 1 is the corresponding equation of x greater than or equal to 1. Now we should not draw the table values. We need not find the table values of x is equal to 1, because it represents a straight line parallel to y-axis. So if any line is parallel to x-axis or y-axis, we need not find the table values. That means we no need to find the extra values of x and y. X is equal to 1 is the line which represents a straight line intersecting x-axis at x is equal to 1. X is equal to 1 represents a straight line intersecting x-axis at x is equal to 1, and it is parallel to the line y-axis. X is equal to 1 represents a straight line which intersects x-axis at x is equal to 1, and the line x is equal to 1 is parallel to y-axis. So we can easily plot the graph of the line x is equal to 1. Now we have to take the testing point. Taking the testing point 0, 0, because 0 does not satisfy the corresponding equation of the inequality x greater than or equal to 1. So while choosing testing point, we have to choose the point which does not satisfy the corresponding equation of the given inequality. So when we put value of x is equal to 0, 0 is not equals to 1. That means 0 doesn't satisfy the corresponding equation. That means we can take the testing point 0, 0. So while choosing testing point, we have to choose the point which does not lie in the corresponding equation of the given inequality. So x greater than or equal to 1 is the second given inequality. Now let's put the value of x 0, 0, x value putting 0, 0 greater than or equals to 1. 0 greater than 1. This is the false statement. That means the inequality x greater than or equal to 1 does not contain the point 0, 0, because 0, 0 does not satisfy the inequality x greater than or equal to 1. So while showing in the graph, first we'll draw the graph of x is equal to 1, then the region will show opposite of the testing point, because the inequality does not contain the testing point 0, 0. So the region represented by x greater than or equal to 1 is opposite of the testing point 0, 0. Now it shows that x greater than or equal to 1 does not satisfy the point 0, 0, doesn't contain the point 0, 0. Now third inequality is y greater than or equals to 2. The third given inequality is y greater than or equals to 2. We have to represent y greater than or equals to in the graph. The first step is we have to change. To plot the graph of any inequality, at first we have to change the given inequality into the corresponding equation. With the help of the corresponding equation of inequality, we can easily plot in the graph. The corresponding equation of y greater than or equals to is y is equal to, which represents the line intersecting y-axis at 2 and parallel to x-axis. Y is equal to 2 represents a straight line intersecting y-axis at y is equal to 2, and the line y is equal to 2 is parallel to x-axis. Now representing all the given inequalities, now taking the testing point 0, 0, because to plot any inequality in the graph, we have to take testing point, because inequality represents a certain region. So we have to take testing point. So let's take testing point 0, 0, and with the help of testing point, we can find the region represented by the given inequality. So y greater than or equals to, this is our third given inequality. So when we put the value of testing point 0, 0, that means when we put value of y 0, then we get 0 greater than or equals to, which is false statement. 0 greater than 2, which is false. That means the testing point 0, 0 does not satisfy the inequality y greater than or equals to 2. Or we can say the inequality y greater than or equals to does not contain the point 0, 0. Or we can say the inequality y greater than or equal to does not contain origin. It shows that the inequality y greater than equals to does not contain the point 0, 0. Now plotting all the given inequalities in the graph. Plotting all the given inequalities 6x plus 5y less than equal to 30, x greater than or equal to 1, and y greater than or equal to in the graph. Now plotting all the given inequalities 6x plus 5y less than equal to 30, x greater than or equal to 1, and y greater than or equal to in the graph. At first, we'll plot the table values of the corresponding equation of first inequality. The corresponding equation of first inequality 6x plus 5 is equal to 30, and already we have got the table values of 6x plus 5y is equal to 30. The x and y values are 0, 6, 5, 0, 10, minus 6. The first point is 0, 6, second point is 5, 0, and the third point is 10, minus 6. So let's plot the first point 0, 6 in the graph. Plotting the first point 0, 6. Plotting the first point 0, 6. X is 0 and y is 6. X is 0 and y is 6. 1, 2, 3, 4, 5, 6. X is 0 and y is 6. 1, 2, 3, 4, 5, 6. So taking scale, the scale of graph I have taken 2 square rooms is equal to 1 unit. Taking 2 square rooms is equal to 1 unit. So 2 square rooms is supposed as 1 unit. We can suppose any number of square room as 1 unit. So in this graph, 2 square rooms is supposed as 1 unit, and x-axis and y-axis, they are marked by taking 2 square rooms is equal to 1 unit. So 0, 6, the first point already we have plotted. Now the second point is 5, 0, 5, 0, 1, 2, 3, 4, 5. X is 5 and y is 0. 1, 2, 3, 4, 5. So 5, 0 lies on x-axis. Now third point is 10, minus 6. The third point is 10 minus 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 6 is the point 6 lies over here. That means 10 minus 6. So we have got 1, 2, 3 points. So now joining all the 3 points by using a ruler. So we get a straight line. 6x plus 5y is equal to 30. So the straight line 6x plus 5y is equal to 30 is already shown in the graph. Now the second inequality is x greater than or equal to 1. So first we plot the graph of the corresponding equation x equals to 1. The graph of x is equal to 1 is the line intersecting x-axis at 1, and it is parallel to y-axis. So easily we can plot the graph of x is equal to 1. And the graph of the third inequality is y greater than or equals to, and the corresponding equation is y is equal to 2. So y is equal to means intersecting y-axis at the point y equals to 2, 0. So 1, 2. So y is equal to 2 is the line intersecting y-axis at y is equal to 2 and parallel to x-axis. So we have plotted the corresponding equation of the first inequality, second inequality, and third inequality. Now the corresponding lines of the given inequalities are also known as the boundary lines. So first boundary line, second boundary line, and third boundary line. Already we have plotted the corresponding boundary lines represented by the given 3 inequalities. Now we know that inequalities, they represent a certain region, and we have to determine the region with the help of testing point. So with the help of testing point, now we can find the region. We can show the region represented by the given inequalities. We have already shown that the testing point 0, 0 does not satisfy. Already we have shown the testing point 0, 0 satisfies the first inequality 6x plus 5y less than or equal to 30. So testing point 0, 0 satisfies the first inequality. That means the graph of the first inequality contains the point 0, 0. The inequality 6x plus 5y less than or equal to 30 contains the point 0, 0. That means the point 0, 0 satisfies the first inequality. So we have to show the region of the first inequality towards origin, because the point origin, or we can say the point 0, 0 satisfies the first inequality 6x plus 5y less than or equal to 30. So the region represented by the first inequality contains the point 0, 0. So we have to show the arrow towards the point 0, 0. Now the second inequality is x greater than or equal to 1, and already we have plotted the boundary line of x is equal to 1. The second inequality is x greater than or equal to 1, and already we have shown that the point 0, 0 does not satisfy the inequality x greater than or equal to 1. That means x greater than 1, x greater than or equal to 1 does not contain the point 0, 0. That means the region represented by x greater than or equal to 1 is opposite of the point 0, 0, because the inequality x greater than or equal to 1 does not contain the point 0, 0. So in the graph we have to show the region represented by x greater than or equal to 1 opposite of the point 0, 0. We have shown that the inequality x greater than or equal to 1 does not contain the point 0, 0. So the region represented by the inequality x greater than or equal to 1 is just opposite of the point 0, 0. So we have to show the arrow, or we have to show the region represented by x greater than or equal to 1 opposite of the point 0, 0. So the arrow shows the region represented by the second inequality x greater than or equal to 1. Now the third inequality, to show the region of the third inequality, we have to take the help of the testing point. Already we have shown that the point 0, 0 does not satisfy the second inequality y greater than or equals to 2. That means the graph of the inequality y greater than or equals to doesn't contain the point 0, 0. We know that y greater than or equals to, that means the third inequality does not contain the point 0, 0. So the region represented by the inequality y greater than or equals to will be above the line y is equal to 2, because y greater than or equal to doesn't contain the point 0, 0. So the arrow we have shown just above the line y is equal to 2, because the inequality y greater than or equal to 2 doesn't contain the point 0, 0. So according to the question, we have plotted the graph of all the three inequalities: 6x plus 5y greater than or equals to 30, x greater than or equals to 1, 6x plus 5y less than or equal to 30, first inequality. Second inequality, x is equal to 1 and x greater than or equals to 1, and third inequality, y greater than or equals to 2. We have already plotted the graph of 6x plus 5y less than or equals to 30, x greater than or equals to 1, y greater than or equals to 2 in the graph. Now we have determined the feasible region and the vertices of the feasible region. We have to determine the feasible region. Feasible region is the region, or we can say area, bounded by all the given inequalities. So the area bounded by all the given three inequalities, according to our question, is the saddle region ABC of the polygon. ABC is the region which is bounded by all the three inequalities. So x greater than or equal to 1, the first inequality, 6x plus 5y less than or equal to 30, shows the region to the downwards. The second inequality, x greater than or equal to 1, shows the inequality to the right side, and the third inequality, y greater than or equals to 2, shows the region upward. That means if we look at the diagram, if we look at the graph of all the three inequalities, then we find that the region ABC, the saddle region ABC, is the common region which is bounded by all the given three inequalities. The common region which is bounded by all the given three inequalities is called feasible region. So triangle ABC is the feasible region, and ABC are the three vertices of the feasible region. The coordinates of the first point of the feasible region A is x value is 1 and y value is 1, 2, 3, 4, 5. That means 1, 5 is the first vertex of the first point of the feasible region. Now let's find out the coordinates of the second point of the feasible region. So B is the second point of the feasible region. So 1, x is 1 and y is 1, 2. That means 1, 2 is the vertices, or we can say coordinates of the point B. Let's find the coordinates of the point C. The point C is x value is 1, 2, 3, 2. So if we put the value of x and y, 3, 2 in the second equation, in the first equation, to find the coordinates of C, we have to put the value of y is equal to 2. We cannot directly get the value of x. We cannot get the exact value of x, that means x coordinate of the point C, because it lies between the 2 points. So we know the value of y is equal to, the y coordinate of the point C is 2. So to find the value of x coordinate, we have to put the value of y is equal to in the first equation, because the point C is the intersection of the line y is equal to and the line 6x plus 5y is equal to 30. So whenever it is not possible to find the value of x or y exactly, then we have to solve the corresponding equation of the two inequalities, which will give the intersection point of the two lines. So when we put the value of y is equal to, we get 5 to the 10, and 30 minus 10 will be 20. So value of x will be 20 by 6. That means x value will be 10 by 3. So the required coordinate of the point C, that means third vertex, is 10 by 3, 2. Hence, So according to the question, the graph of the inequality 6 plus 5y less than or equal to 30 and x greater than or equal to 1 and y greater than or equals to is shown in the graph with the help of corresponding equation and the testing point. Thank you. Thanks for watching this video. If you like this video, please subscribe my YouTube channel Karna Maths Academy and don't forget to hit the notification bell icon so that you will get daily updates. Thank you. Thanks for watching this video.